Hi friends, welcome to AKP Study Circle. In this video, I would like to discuss current electricity practice sheet questions. And in this series of videos, in the first phase, I am going to cover current electricity, electromagnetism, electromagnetic induction, and ray optics. And relevant to current electricity, I will discuss 6 worksheets or practice sheets, and electromagnetism, 1 practice sheet, electromagnetic induction, 1 practice sheet, and ray optics, 6 practice sheets I will discuss. Using these practice sheets, I am going to cover total syllabus and total model questions relevant to these topics. And this will be useful for JEE, NEET, and EEE government jobs and other relevant government jobs. And currently regarding current electricity, practice sheet 1 questions completed, and regarding practice sheet 2 questions we are discussing in this video. And if you are first time watching my channel, please subscribe to my channel and press the bell icon so that you will get the video notifications. And the first question, a metallic wire of resistance 20 ohms stretched until its length is doubled. Its resistance is. In the previous video I have discussed the formula for this question. The new resistance is equals to n square into the old resistance. Okay. You can use the same formula here. N means here it is getting doubled. Just substitute here. It is double means it becomes 2 whole square into resistance how much given? 20 given. So 2 square means 4. 4 into 20 you are getting 80 ohms. Okay. And for this type of model, if it is getting double, we have to replace with 2. If it is getting off, we have to replace with 1 by 2. If it is getting 1/4, you have to replace with 1 by 4. Just substitute in n value, you will get the required answer. And next question, the temperature coefficient of wire is 0.00125 per degree centigrade at 300 Kelvin. Its resistance is 1 ohm. The resistance of the wire will be 2 ohms at which temperature? And this is a very important question and mostly repetitive model. And initially write the given data. What is given? 300 Kelvin. Its resistance is 1 ohm given. So resistance R1 equals to 1 ohm, and resistance, second resistance how much given? That is 2 ohms given. And first temperature how much given? T1 equals to 300 Kelvin given. Just convert this into degree centigrade. What will happen? Subtract with 273. Okay. Subtract with, just for getting into degree centigrade, what you have to write? That is temperature in kelvins minus 273. Okay. Substitute here. That is 300 minus 273 equal to 27 degree centigrade. Okay. And temperature coefficient how much given? Alpha equals to 0.00125 per degree centigrade. Okay. Per degree centigrade given. And what is the resistance of a conductor formula? R1 equals to R0 into 1 plus alpha into T at T1 temperature. Okay. Resistance of a conductor at T1 temperature and resistance of conductor at 0 temperature, and this is the temperature coefficient and this is the temperature at T1. And the resistance of conductor at T2 temperature is R2 equal to R0 into 1 plus alpha into T2. Just simplify this equation 1 by equation 2, that is R1 by R2 is equals to R0 into 1 plus alpha T1 by R0 into 1 plus alpha T2. Just R0 cancel and just substitute the values. What you have to calculate? You have to calculate the T2 here. Okay. T2 not given. The T2 value you have to calculate in kelvins. And substitute the values. R1 means 1. So 1 by 2 equals to 1 plus alpha. Don't substitute the alpha value here and it will be lengthy, and you can substitute at the end. Okay. Alpha and T1 how much given? T1 you got 27 degrees. Okay. 27 by 1 plus alpha T2. You have to calculate. Okay. You can substitute here, but it becomes little lengthy. Just substitute at the end after for the simplification. And do cross multiplication here. And what you will get? 1 plus alpha T2. 1 plus alpha T2 equal to 2 into this one. That is 2 plus alpha into 27 into 2, 54. And in these two take common. this take common, that is alpha into T2 minus 54, send that side, T2 minus 54 equal to 2 is here, 2 minus 1. Okay. So what you will get? T2 minus 54 equals to 1 by alpha. What is the alpha value here? You can substitute here. T2 equals to 1 by alpha value, how much given? Temperature coefficient 0.00125. Just substitute here. 0.00125 plus 54. Okay. So if you simplify further, after point, how many zeros are there? 0.00125. Total 5 digits are there. So write 5 digits or 5 zeros here by 125 plus 54. Cancel this. 25, 5s are 125 and 25 4s are 100. Remaining 3 zeros are there. So 5, 8, 40. Okay, 5 8s are 40 and remaining 2 zeros you are writing here. That is 800 plus 54. 854 you are getting. Okay. How much you are getting? 854 you are getting. This one you are getting in degrees. Okay. This one you are getting in degrees centigrade. Just further add 273. Okay. You know this. For getting it to Kelvin, what you have to write? You have to send this side. Okay. Temperature in Kelvin's formula, that is you have to add the 273. So 854 plus 273. How much you will get? 4 plus 3, 7, 7 plus 12, 1 is there, 8, 2, 10, 1, 11, that is 1127 Kelvins you are getting. So this is the correct answer. And here common mistake is, here temperature coefficient per degree centigrade given, and don't forget to convert this into degree centigrade. Okay, don't forget to convert this into degree centigrade at the starting, and at the end, based on the options, you need to convert into Kelvins. Okay. Next question. Two wires made of same material have lengths in the ratio 1:2 and the volumes in the same ratio. The ratio of their resistances. Okay. What is the given data here? Lengths L1 is to L2 equals how much given? 1:2 given. And volumes ratio also given same here. E1 is to V2 equal to 1:1. And he is asking ratio of the resistances. That is R1 is to R2 equal to how much is asking. Okay. So you know relevant formula, resistance, length, volume relevant. You know R equals to rho L by A here. Okay. Here same material given. So here rho is constant here. Okay. So you have resistance, length and area. In terms of area he has not given. He has given in terms of volume given. So try to convert this into volume. R equals to rho L by A. Area, what you can write here? You know, volume equals to length into area here. So in place of area, what you can write? In place of area, what you can write? In place of area, you can write volume by length. Just substitute here. V by L here. What you will get? R equal to rho L by V. So L goes to numerator, so it becomes rho L square by V. So you are getting the formula. R is proportional to L square by V. So based on this relation, you can derive the formula. So based on this, what you can write here? R1 by R2 equals to L1 by L2 whole square into V2 by V1. Just substitute here. So L1 by L2, 1:2 given. Just substitute here. 1 by 2 whole square into V2 by V1, how much given? 1:1, same ratio given. So 1 by 1. So 1 by 2 whole square means 1 by 4. 1 by 1 means 1 only. So 1 by 4 you are getting. 1:4 is the required answer. So this is the correct answer. Next question. Two wires made of same material have their lengths are in the ratio 1:2 and their masses are in the ratio 3:16. The ratio of resistances of two wires respectively is. And what is the given data here? L1 is to L2 how much given? 1:2 given. And masses are in the ratio 3:16. So M1 is to MT equal to 3:16. What he is asking? Ratio of resistances is asking. So R1 is to R2 equal to how much you have to calculate. Okay. Same model, just derive the required formula from the actual one. R equals to rho L by A here. Okay. So resistance, length, area, okay. In terms of area, he has not given. He has given in terms of masses. So we need to convert this into masses. So based on the previous question, what you have written here, rho L by A can be written as volume equal to length into area. So area can be written as volume by length. So what you can write, volume by length means volume by length. What you are getting, rho L square by volume you are getting. Okay. You need to simplify further this one, okay. In terms of getting into masses, R equal to rho L square by. So volume can be written as, you see here, mass density volume. Just triangle. So mass equal to density into volume and density equal to mass by volume. Here what you can write here, in terms of volume we need, okay, volume equal to mass by density. Substitute here, volume equal to mass by density, what you will get here, that is rho L square by mass into density, okay. So what you are getting, relation, R is proportional to L square by mass here. Here density is constant here. So R is proportional to L square by M. So R1 by R2 equals to L1 by L2 whole square into M2 by M1. You have to remember this formula. In the previous one, what you have got, V2 by V1 you have got. In this, M2 by M1 you are getting. Just remember this formula, you can directly answer in exam. Just substitute the values here, R1 by R2 equals to L1 by L2 how much given, 1 is to 2 given, so 1 by 2 into M2 by M1, M1 is to M2, 3 is to 16, so M2 by M1 means 16 by 3 you are getting, 16 by 3, and here whole square is there, so write whole square here, how much you are getting, so 1 by 4 into 16 by 3, so 4 4s are, so you are getting 4 by 3, so required answer is 4 is to 3. Next question. A wire of resistance 18 ohms is drawn until its radius reduces 1 by second of its original radius. Then resistance of the wire is. And here he is asking radius reduces 1 by second he is giving. Over radius reduces to 1 by second. Don't use this formula R equal to N square R. Don't use here. This is for if length is doubled, if length is tripled. For this you have to use. If length is double, triple of, we have to use this. Okay, don't use this here. Okay, here he is asking, its radius reduces 1 by second of its original radius, then resistance of the wire is asking. So for this kind of model, the formula is resistance equal to N power 4 into R. Just substitute this. Reduces to 1 by second each. Okay, just substitute here. 2 power 4 into R. How much you are getting? 2 to the 4, 4 16, that is 16 into resistance how much given? 18 given. So if you multiply how much you are getting? 288 ohms you are getting. If same model given 1/3, 1/4, so any 1/5, if they are given like this, in the denominator whatever it is there, just take that as the value here. 1 by second given, so substitute the 2 value. Don't take 1 by 2 here, okay. Don't confuse with this. And thanks for watching this video. Please like this video and share this video with your friends. And don't forget to subscribe this channel for more videos. Thank you.